Hi friends, welcome back. Today we are going to solve another very recent and very important Leetcode coding interview question 2641, cousins in binary tree 2. As you can see, this is another likable medium complexity binary tree related coding interview problem that we are going to go through today. This is quite interesting problem, so make sure you watch this video until the end so you completely understand this important problem. If you are new to this channel, please subscribe to this channel now. Also click on the bell notification icon button right away so you won't miss any important postings from this channel. Here we create videos to help others in their interview preparation and learning different computer science concepts along with data structures, algorithms, problem solving, logic building, programming and coding. So let's start. Given the root of a binary tree, replace the value of each node in the tree with the sum of all its cousins' values. Two nodes of a binary tree are cousins if they have the same depth with different parents. Return the root of the modified tree. Note that the depth of a root node is the number of edges in the path from the root node to it. Okay, so that is the definition of a depth of a node. So we'll go through the examples. Constraint says that the number of nodes in the tree is in the range of 1 to 10 raised to 5. So maximum 1 lakh nodes will be there in the tree and the node values will be between 1 to 10 raised to 4 inclusive. Right? So that's what they are saying. So the important thing here to understand is what are the cousins of a binary tree, right? So there are two nodes of a binary tree are cousins if they have same depth with different parents, right? So let's understand this first so that it will be clear for you. So let's say we'll just draw a sample tree basically without values, so I can explain you first what that means, right? Because it's important that you understand this first, right? Then you can easily understand the approach as well as the solution. So let's say this is your binary tree, right? So it will go like this, right? Basically uh, if it is full binary tree, you will have full binary tree like this, correct? So now what are the cousins here basically, right? So the cousins here in this binary tree is, for example, for this node, right? For this node's parent is this, right? So this parent's brother or sibling, basically this is his sibling basically, correct? This is the sibling, its children are the cousins. So these are the two cousins of this node. So this node has two cousins, right? This node as well as this node, correct? So this is the definition of a cousin. Okay, and same thing, like this node also has these two cousins, right? This node also has these two cousins. Why they are his cousins? Because they are his parents siblings children. Basically his parent is this one, right? And his sibling is this, and these are the children of their siblings, right? So these are the cousins of these two nodes that I have shown you, correct? Now if I want to take this node, which are the cousins of this node? So the cousins of this node is so his parent is this node and his parent's brother. So parent's brother is who is the brother? This is the brother of his parent, right? So these are the two siblings of this node, right? These nodes these are the cousins basically, right? Cousins of this node, right? So this is the definition of a cousin, right? Okay, so we want to find out um, like let's take a look here, right? This example. So you can see that for this node 1, right, the cousin node is 7 here, right? For node 1, so node 1's cousin is 7, so you will have to put the sum of the cousins. So only one cousin, so you will put 7 here. Node 10's cousin is also 7, so you will put 7 here for 10, right? Node 7 has two cousins, 1 and 10, correct? You got it, right? So the sum of the cousins is 1 plus 10 is 11, so you have to put 11 for the 7 because it has two cousins, right? 1 and 10. So that is what it means basically, correct? So this is, and 4 does not have any cousin, so you will put 0. 9 does not have a cousin, you will put 0. 5 does not have a cousin, you will put 0, right? So this is what they are saying. Given the root of a binary tree, replace the value of each node in the tree with sum of all its cousins values, right? So let's take another example. So this is another example I created, right? So 50, this is the root. So 50 does not have any cousin, so you will put 0. So this is straightforward. 10 does not have any cousin. So for 10 you will put 0. 8 does not have cousin, you will put 0 for it, right? So this is the output tree that I am showing you. This is the output tree we want to create, right? This is the output tree. Okay. Now, what about node 20, right? This node 20. So who are the cousins of this node 20? The parent of node 20 is 40. The parent of node 20 is 10 and 10's sibling is 8. So 8's children are the cousins of 20. So these are the two cousins of 20, right? So what is the sum of the cousins? 50 plus 16 is 66. So that's what you will put here. Correct? So this point is clear, right? How this 66 came. Okay. Same 66 you will have to put for 40 because 40's cousins are again 50 and 60. 40's cousins are again 40's cousins are 50 and 16. Why? Because 20 and 40 are siblings. So if 50 and 16 are are cousins of 20, it also means that they are also cousins of 40. So you will again put 66 here for 40, right? And you understood why that 66 came, right? 15 plus 16 is 66. So far so good. So you understood this, right? So let's keep going. Now if you want to find out who is the cousin of node 50, right? So 50's cousins are these two are 50's cousins, correct? So what is the sum of them? 40 plus 20 is 60. So you will put 60 here, right? So this is what we want to do. Who are the cousins of node 16? Who are the cousins of node 16? Again, these two nodes are the cousins of 16, right? So 20 plus 40 is 60. You will put 60 here, right? So this is what the problem is asking. So you understood this problem clearly now, right? With this example. So how can we solve this problem? So now the best way to solve this problem is using BFS. We'll use a BFS here, right? BFS stands for breadth first search or breadth first traversal. And this is also many times called as level order traversal, right? And this is very useful technique when it comes to binary trees, binary search trees, graphs, matrices also. So how will BFS help us solving this problem? So BFS uses queue, right? So we will also use queue here. So using BFS, we will start looping through each level. So these are the levels, right? This is level 1, level 2, right? Level 3. So these are the levels basically in the binary tree. So far you understood this, right? So what we will do in the BFS, you keep uh, from the root node, you will keep removing this node and you will keep adding it into the queue. So you will maintain one queue here, right? So first node you will add into the queue is node 50, which is the root node, correct? So this is your queue, right? And this is the front of the queue. So you will start with node 50, which is your root node, right? Okay. Now you will also keep one variable which will give you the sum, right? Sum for the previous level you will get. So for sum for the previous level is 0 obviously for root, right? So you remove 50, you add its children, left and right child, right? 10 and 8. So 10 is the left child, 8 is right child. The sum of previous level is 50. So far so good, right? Whenever you process a node for that level, you will keep adding it into the sum. So your sum is 50 now for previous level, right? This is your previous level now, 50, right? Okay. And now you will start processing these elements for the next level. So this level is done, you process 50. Now you will go to this level, right? You will start processing these two nodes. So you remove 10, right? And you removed 8. Your total is 10 plus 8 is 18. So your sum is 18, right? Which is your previous level sum. You will add its left and right child. So 20, 40 are the left and right child of 10. So you will add 20 here. You will add 40 here. After that, you will add 50 here, which is left child of 8. And you will add 16 here, which is right child of 8. So far you understood, right? So this is straightforward. At the same time, whenever you are processing the nodes, you will also keep track of the siblings. How you will keep track of them? You will add them into a map. The map you will create. Map will tell you who are the brothers basically here. For example, who are the brothers? That's what the map will tell you. So 10 and 8 are brothers, right? For example, 10's brother is 8, right? And 8's brother is 10, right? So this is clear, right? So this one you will keep track of the brothers here. So brothers is basically like this, right? They have same parents. So let's call it as a brothers, right? Typically they call it as a siblings. We'll call it as brothers here. Okay. So 10 and 8 are brothers. So you add that relationship into the map. So far clear, right? Okay. Now you start processing this level, right? Okay, so you start processing this level. Now for this level you will uh, remove 20, 40, 50 and 60, right? And you will keep track of the sum. So sum of these nodes is 20 plus 40 is 60 plus 50, 110 plus 16 is total sum of this level is 126, correct? All the sum of all these nodes is 126, right? Now when you process those nodes from the BFS, you removed all them, right? And you also kept a relationship who are the brothers of each other. So 20's brother is 40, right? 40's brother is 20. It is bidirectional, right? Both are brothers of each other here, correct? 50 brother is 16, right? 50 brother 16 and 16 brother 50, bidirectional relationship. So far good. Okay, now you also know the total sum of this level, right? Okay, when you are processing, now you added this, now you will start processing them, right? You will start processing 20. So you will check if this does not have now you know the sum of this total nodes, right? 126. You know the sum of this total node, which is the uh, current level sum basically, right? This current level sum. Now you know that the 20's brother is 40 because of the map. You know that 20's brother is 40, right? So it means that you can find out the sibling sum, right? How you will find out sibling sum? Because if we know 126 is the total sum, I know the current node is 20. I know its brother is 40, so I will have to subtract them basically from 126. So I will get 66. Agreed? So this point is very clear, right? So total sum of all the nodes on that level is 126. I know the current node I am processing is 20. I know its brother is 40, right? So I can subtract 60 from that total sum. So I will get 66 that I want to put here basically, correct? So I will put 66 here basically, correct? Okay. So same thing for 40. Same thing for 40, right? 126 minus 40 minus 20, it will give me 66. So I will put 66 here, right? Because 40's brother is 20. What about 50? When I'm processing this node 50, right? What I will do? I know the total sum is 126. My current node I'm processing is 50. And who is the brother of 50? 50's brother is 16. So I'll minus 16. So if I calculate this, then I'm going to get 60, right? So this will give me 60. So I will put 60 here, right? You got it, right? So this is because for every node we want to find out the total sum of all its cousins. So who are the cousins of 50? These are the cousins of 50, right? 20 plus 40 is 60. That's what I'll put. Same thing for 16, right? 16 also I will have 126 minus 16 minus 50, but it will give me the same amount, 60, right? That I'll put here. So this is the basic idea basically, how we will use BFS, how we will use map. So map is essentially to keep track of the siblings basically, siblings, right? Or brothers is here, right? So that's what the map is used for. So if we know the brothers, then I can easily calculate this remaining sum if I know the total sum of that level, right? So this is the basic idea to solve this problem. So I hope you understood this clearly now with this logic. So let's go ahead implement this same logic in Java. So this is our Java code for this replace value in tree, right? So tree node root is given to us. This again returns a tree node root of after the replacement, right? So we are going to create a map which will hold the siblings relationship that I just mentioned you. It is going to hold a tree node and integer, right? So this is the map. It is a new hash map of tree node and integer, correct? After that, since we are going to use BFS, we will need queue. So we will use a java.util.queue of tree nodes, which is essentially a linked list in Java, right? So the linked list or queue is going to hold queue tree node objects, right, of the binary tree. We are going to start by adding the root node into the queue because we have to have something into that queue so that we can do the BFS. Sum is equal to root dot value, right? Now this is the point where our BFS starts, right? So BFS starts here. So while queue is not empty, you want to process all the nodes, right? So you will check the current size of the queue and you will set the current level sum as 0 and you will start basically what this BFS or level order traversal does is it goes level by level, just as I explained you here, correct? We go level by level here, right? So while size is not equal to 0, you will keep processing all the nodes for that level. You will keep polling the nodes from the queue. Poll will remove the front node from the queue, right? Poll will remove the head from the queue. So you will get the current node. You will subtract that value from your total sum for that level, right? Sum for the previous level basically, right, that you have. So sum minus current node dot val will give you the remaining, right? For example, when you are processing this node 20, you already have the total sum you already calculated for that level is 126, right? Because 20 is what you will process, but before that you have to add all these nodes for that level, right? So you already know this sum for this level, right? That's why you know this sum basically 126 for example. Now you have to subtract the current node value here and you will check if that current node that you are processing has a sibling, right? So you will check if the sibling is there in your map contains key current node value. So you are checking if the brother value is there. You want to get that and subtract it from the remaining, right? So what we are essentially doing is, let me remove all this so I'll explain you again so it will be more clear for you how the code is working, right? So when we are we know the total sum for this level, right, last level. So let's just focus on the last level. So total sum we already calculated in the BFS when we added these nodes into the queue. Let's say you have added these nodes, right, 20, 40, 50 and 16, right, 50 and 16. Now you want to process it, right? And you already have the information into the map who is the brothers, right? So 20 brother is 40, 40 brother is 20 because it's bi-directional relationship, and 50 brother is 60, 16, and 16 brother is 50, right? So you already have this now, right? Now when you are processing this node through BFS, you remove it from here, right? Now you will subtract this 20 value, right? Now you are checking if it has any brother. So 20 has any brother? Yes, you have a brother here in the map. Its value is 40, so you will subtract that value also from here. So you will get the value 66 and that value you will put here, right? So this is exactly what we are doing here. So here, right, map dot contains key current node, so it's checking the brother value or sibling value, and if it has any brother or sibling, you are going to subtract it from your remaining value. So remaining is equal to remaining minus map dot get current node, and then you will update the current node value is equal to remaining, right? And you will check now if it has a left node which is not null, then you have to add it to the queue, right, for further processing through BFS, right? You will only add if it is there, right? If it's not there, you will not add, right? So if it is there, you will add it into the queue, correct? Queue dot add current node dot left, and you will count that as your sum, current level sum, right? You have to add it into your current level sum, current node dot left dot val. Then current node dot right is not null. Then you have to also add the relationship, the brothers relationship or sibling relationship we are maintaining in the map, right? So we have to add that relationship, correct? So it means that for 10 means you are for this node 10, your left child is 20, so its right child is 40. It means that 20 and 40 are brothers, right? That relationship we are capturing here, correct? Same thing you will do when you are going and processing the right child node, right? So you will check if your current node has a right node as a child, right? Then you will add that right node into your queue for further processing through BFS. You will add that value of your level into the next level sum, basically, correct? And then you will also make sure that you capture the relationship, the brother relationship. It means that when you are saying that 10's child is 40 and 10's child is also 20, then 40 and 20 are also brother, right? So it's a bi-directional relationship, right? So you have to maintain that into the map, correct, here, right? So I also wrote the comment mapping between right and left sibling or child, right? After that, you will keep looping, processing all the nodes in the while loop. So we are in a while loop here, right? So this while loop and this while loop, there are two while loops. So this inner while loop is processing all the nodes for that level, right? So this while loop will end here. The inner while loop ends here, right? So I'll write down here, right? Inner while loop end, right? And then you will just update your sum to the current level sum, right? So that you know that sum, basically, correct? And at the end you will just have to return the root. So you will be actually getting this tree, this output tree you will get at the end, right? So this is how you can solve this problem. So I hope it is pretty clear now with you how we have used a BFS and queue approach to solve this Leetcode coding problem, cousins in binary true 2. So we are going to run this code now, make sure it gives us correct answers. So for the first example, we are expecting 00077 null 11 correct answer, as you can see here on the screen. And for the second example, we are expecting 000 correct answer. Submit this code to the Leetcode, make sure it gets accepted. And as you can see, the code is successfully accepted by the Leetcode. It is 100% faster on both performance and memory usage, which is a very good solution to solve this coding problem that uses BFS and a queue approach. So I hope you understood how we have used the BFS and queue approach to solve this coding problem. BFS is also widely known as level order traversal because it goes level by level, right? And this is a perfect case where we can use a BFS to solve this problem. So I'm going to add this Java solution code for you in my GitHub repository and give you the link of my repository code, so you can check out the other solutions there as well. There are lots of other programming and algorithmic solutions we have already implemented are available there for you. Don't forget to check them out. They are important ones from interview perspective, will help you learn more computer science and programming techniques there. If you like the programming solutions in the GitHub repository, consider giving it a star on the GitHub repository. That would be great. If you are new to this channel, there is a very important coding interview related playlist we have created to help your interview rounds. It is called as Leetcode and Leetcode Solutions. More than 200 most frequently asked very important coding interview problems are compiled for you under one playlist. Those problems are asked by many big companies including Google, Facebook, Amazon, Apple, Microsoft, Yahoo, Uber, Lyft, LinkedIn, Netflix and many others many times in their past interviews. They are very important coding interview problems. Make sure you go through all of them, understand them thoroughly. If you go through all those videos and problems, you are going to learn a lot about data structures, algorithms, problem solving, logic building, Java programming and coding. It will also help you learn lots of new techniques, lots of new ways of problem solving. So do check out the Solve Coding Problems. The name of the very important playlist for you is Leetcode and Leetcode Solutions. Now, if you are a fresher, junior level developer and you want to practice more coding problems for your interviews, To help you with your practicing, we have created 3 other playlists for you on this channel. The names of those playlists are Code Forces, Code Chef, and Coder. Go to the playlist of this channel. You'll find those playlists listed out there. Lots of interesting, important, and exciting problems are waiting for you there. So do check out those problems. If you like today's video, if this video has helped you understand how to solve this Leetcode 2641 cousins in binary tree 2 using BFS and Q approach, then please give it a thumbs up to the video, give it a like to the video, subscribe to this channel. Subscriptions are very, very important because that's how the videos can reach to other people, so others will also be able to watch and learn from this channel. So do subscribe to this channel, share this content with your friends, your colleagues, so they will also learn problem solvings and programmings and Java coding. Click on the bell notification icon button right away, so you will always get immediate notifications for all our exciting and upcoming videos here. If you are a fresher, junior level developer, and you want to learn how to solve different coding interview problems for in interviews, right? You want to learn how to use different data structures and algorithms in those problem solvings, and you want to learn how to do the Java coding and implementations. To help you with all that, we have created lots of solve coding problems videos on this channel that you can use to prepare well for your coding rounds of interviews, as well as learn more computer science concepts and data structures. The important varieties on this channel includes graphs, matrices, binary search trees, breadth first search, depth first search, cadence algorithm, binary search algorithm, Kruskal's algorithm, Dijkstra algorithm, sliding window algorithm. There are lots of other important data structures related coding interview problems available for you here, including stacks, queues, priority queues, hash table, hash map, tree set, hash set, linked hash map, linked hash set, arrays, linked list, all are here on this channel to help you learn how to solve different problems and how to do the implementations using Java and J2EE. If you are planning to take Java interview rounds, then there are lots of Java related videos we have created to help others on this channel. For example, frequently asked Java telephonic interview questions and how to answer them, Java design patterns, Java architecture, SQL programming questions to the freshers, where they will give you database tables. They will ask you to write SQL queries, where you may have to use different database concepts like inner join, outer join, left outer join, right outer join, aggregate operations, group and having clauses, different where clause conditions, MySQL, important windowing and ranking functions along with partitioning. Everything is demoed and explained with MySQL database tables as well as SQL queries for you on this channel, so that you can easily understand and follow those SQL related solutions. There are videos that captures recently asked questions about Unix. For example, Unix commands, Unix utilities, shell scripting questions, all are here on this channel for you to help you in your interview preparation and learning computer science concepts. If you like the videos on this channel, if they're helping your learning process, you are learning more techniques, more problem solvings along with programming and coding, then please do leave your messages, feedback and comments below these videos. Your feedback, your messages and comments are highly appreciated, very, very important and valuable for us. They increase our motivation to create more quality content videos on this channel to help others. So others can also learn problem solvings, others can also learn programming. So do leave your messages if you want us to create videos about any specific computer science, Java, J2E or interview related topics, then mention those topics as well in the below comment section so that we can create those videos for you here. Keep learning, keep coding, keep solving more varieties of coding problems, and most importantly, keep your learning process and practicing going on continuously. And thanks for watching these videos.